Very good morning to everyone. In this lecture EC8652 wireless communication, today we are going to discuss about the topic Gaussian minimum shift keying. The introduction of this GMSK is a binary modulation. Is one of the binary modulation that is derived from minimum shift keying technique. That is a MSK technique. By applying the Gaussian low pass filter with MSK, a GMSK signal can be derived. Here, the continuous phase digital frequency modulation. It is one of the continuous phase digital modulation method. The modulation index H is equal to 1 by 2 ratio. That is a deviation ratio of the modulation index. And also the Gaussian frequency shaping filter are used. So the GMSK is equal to MSK plus Gaussian filter. And also the characteristics of characterized by the value of the bit durations, that is a t equal to bit duration, b is a bandwidth of the shaping filter. So this GMSK and 0.3 for the global system for mobile communication technology and the 0.5 for the digital enhancement cordless telephone, the DECT. So the data rate is 270.8 kilobits per second. That is a band with the time period of the digital signals. In this modulation, not return to zero waveform through the pre-modulation pulse shaping filter with a Gaussian channels. The output is obtained with reduce the side lobe in the transmitter spectrum. The GMSK signal can be concurrently or non-concurrently detected like a phase shift keying. So now let us move to the signal representations. The signal using the MSK modulation, the input signal, so the signal is represented modulated the minimum shift keying. So the performance measurement, it is a GMSK modem is qualified by the measurement of the signal to noise ratio versus the bit rate, that is the error bit rate. So the signal to noise ratio is related to the bit rate and the signal noises. So the frequency and bitrate offset of the carrier signal is a spectral density of the MSK and also the GMSK signal. So the relatively amplitude level of the signal will be increased or decreased due to the frequency bit rate offset of the carrier signals. Now let us move to the generation. This is a GMSK generator. So in this method, the GMSK of input signal, that is a non-return to input data, is applied to the Gaussian filter. So here the two method of GMSK transmissions are used. This is one of the GMSK modulation or transmission technique. The two transmission techniques. Number one, frequency modulated, that is a frequency modulated technique, that is a voltage control oscillator, FM to VCO technique, and the second one is a quadrature modulation. In this technique, it consists of the Gaussian low pass filter and also the FM transmitter with voltage control oscillator and also the RF amplifier. The non-return to zero data is applied at the input of Gaussian low pass filter and then to be FM transmitter. The output of this unit is given to the RF amplifier, from which the GMSK signal output is exacted and then transmitted. So in this generation of the GMSK signal is a simple scheme to adapted to a GMSK transmitter. The input data is given to the Gaussian low pass filter. It is also as a pre-modulation filter. The impulse response of the low pass filter is given by h of t, and h of t is equal to root of pi a in the expression of minus pi square divided by a square t square. Now the output of the Gaussian low pass filter is passed through a FM transmitter. It is of direct FM generation process. In such modulation is implemented in GSM, that is a global system for mobile communication, and continuous discrete pulse modulations. and also the cellular digital packet data methods. And then the output signal is FM transmodulated is passed through the RF amplifier circuit. The final radiated signal is the GMSK signal. And then the GMSK is used several wireless data communications protocols. What are the different modulations? That is a cellular data packet protocols and multi-text system protocols. The cellular radio system data transmit the packet on ideal cellular voice channels. The data rate transmitted at 19.6 kilobits per second with bandwidth. The bit duration is a 0.5, so a high data rate is capable with 330 kilohertz under the channels spacing and the guard time rate. So the cellular digital packet data system guaranteed the widespread radio coverage and also the ease of adaptation. The Mobitex system is dedicated data systems. It is a lower data rate than the cellular digital packet radio network. It says the 80 kilobits per second. It does not share its channels with the cellular voice transmission. It has the total bandwidth is equal to the 0.3 and afford to trigger the channel space 12.5 kilohertz. Now we can compare the cellular digital packet radio system. The system has better inter-symbol interference tolerance. So the both cellular techniques is a CDPD and a Mobitex system employ the forward error correction technique in the packet transmissions. So in this GMSK offer a straightforward spectral efficient modulations for wireless data transmission system, and also the transmission of in I and Q modulator method is widely used. What is I and Q? Is in space and quadrature modulations. The quadrature I and Q modulations is a effective method is eliminate the synthesize shortcoming messages, and also the synthesizer unit is used to GMSK generation. There is a problem that does not respond to low frequency. The consecutive first and zeroth may not recognized by it. This problem or allow only the high frequency signal is overcome in the quadrature I and Q modulator. Now we can move to the bit error rate of the GMSK. The GMSK bit error offers the better performance within 1 decimal of optimum MSK. Here when the 3 dB bandwidth bit duration product BT is equal to 0.25. So the error probability, what are the bit error probability of the GMSK transmission is PE is equal to Q into root of 2 gamma EB divided by N naught. Here where the gamma is equal to 0.85 or 0.65 for GMSK with the total bandwidth is equal to 0.25, and also the 0.68 or 85 for the MSK, the total bandwidth is a infinity level. So and the gamma is constant related to the total bandwidth of the GMSK signal. Now let us move to the properties, Gaussian minimum safety keying properties. So there are the different level of properties are there. First one is improved spectral efficiency. Second one power spectral densities. Third one reduced main lobe over MSK. Fourth one require more power to transmit the data than many comparable modulation schemes. Self-synchronizing capability and a constant envelope over enriched bandwidth, and also the finally good bit error performance, good bit error rate performance. Now we can move to the application of Gaussian minimum safety keying methodology. It is most widely used in global system for mobile communication, and it is used for the cellular digital packet radio over the network protocols, and it is used in the GPRS systems. Now, what are the advantages and disadvantages of GMSK signals? First of all, the advantages, it is a high spectral efficiency of the output signal, and it reduces the sideband power ratio, and excellent power efficiency due to the constant envelope of the signal, and a good choice for voice process modulations. And what are the disadvantages of a GMSK signal? It is a high power level than QPSK and required more complex channel equalization algorithm such as the adaptive equalization algorithm is more complexity in the receiver side, and also it is a smaller symbol interference noise will be occurred. Thank you for watching this video.